Alright, so when you navigate to a site that uses a service worker to handle fetch events, the browser asks the service worker for a response. This involves booting up the service worker if it isn't already running and then dispatching the fetch event. The boot up time depends on the device conditions, so it's usually around 50 milliseconds, but on mobile, it's more than 250 milliseconds, and in extreme cases, like for instance a slow device or let's say a problem in the CPU, it can be over 500 milliseconds. The boot up time isn't a problem if you are responding from the cache, but if you are responding using the network, the request will be delayed by the service worker booting up. So to solve this, we use navigation preload. Now the navigation preload is a feature that lets you say, hey, when the user makes a get navigation request, start the network request while the service worker is booting up. The startup delay is still there, but it doesn't block the network request, so the user gets the content sooner. There's actually a demo video for this which I'll link in the description, where someone tries to simulate a service worker boot up delay. When they disable the navigation preload feature, the fetch response takes the total request to response time plus the boot up time. When it's enabled, it only takes the request response time as the boot up happens simultaneously. But how do we implement this in our application? It's actually very simple. So first we need to enable this feature. This should be done when the service worker is activated. So I'll attach an activate event listener to this service worker. So right below the install event listener, we'll first check to see if there is support for the navigation preload. If that is the case, then we'll simply enable it. So I'll actually put this inside wait until, and wait until, as I'd already mentioned in the previous video, is going to keep the service worker under the activate state until and unless the task inside this wait until function is not completed. So the task that we are going to perform inside this wait until is to enable the navigation preload. So this is going to be an asynchronous function. Now inside the cache match function, right before we make a network fetch request, we'll check to see if there's a preloaded response. If that is true, then we'll again store it in the cache for future use and then return this response. We get the preloaded response from the event object inside the fetch event if there is any. So let's add that to the cache match function's argument list. This will be the event.preload response. And now inside the cache match function, we'll be doing something similar to the network response section. This will be the preload response. This is what we were getting from the argument list. If this is true, then we'll open the cache. Actually, I'll simply copy this whole thing. And instead of network response, I'll just replace it with preload response. Let me just quickly save this. In the browser, you won't really find any changes. It's still going to be the same. Now let's take a look at some improvements that we can make when the service worker gets updated. So in the previous videos, you must have seen me manually clicking on the skip waiting option anytime I updated the service worker. It essentially deactivates the older service worker and activates the newer one. But even after the activation, the web page still uses the older service worker. That's also the reason why every time I clicked on the skip waiting option, I then reloaded the page. So let me just quickly add something over here, a console log statement. I'll save this. If I go back to the browser, you'll see that we have a new service worker that is waiting to be activated. Once I click on this, it is now activated, but this page still uses the older service worker. So I'll need to reload it once and only then will it start using the newer one. Now instead of doing this from the browser, it can also be done programmatically. The first step was to activate the service worker by using the skip waiting button. A similar implementation of skip waiting is available inside the service worker context. So at the top of the install event listener, I'll just attach the skip waiting method. This is now going to do the same thing that we were doing manually. So let me just save this. And if I go back, now you see that we don't get an option to activate the service worker manually. It does it automatically. So let me just add one more space here and save it. If I go back, now from 493 to 494, the update is going to be happening automatically. So the next step was to simulate the reload that we did right after the skip waiting. For that, we have the claim method on the client's property. We'll add it inside the activate event listener. So at the top here, I'm just simply going to use clients.claim and I'll put this inside wait until again. Now, since this returns a promise, I can simply respond back with a console log message. Now, if I save this and go back to the browser, inside the console, you'll see that the service worker has now claimed all the clients. So this new service worker is now basically controlling all the pages that were under the control of the older service worker. So now when you update anything inside the service worker, it's automatically going to activate and eventually take control of all the web pages. And with that, we are done with the caching part of this series. Now in the coming videos, we'll be taking a look at communication with the help of notifications. So do subscribe for that. And if you have any doubts or suggestions related to the caching part of this series, do put it in the comments. And yeah, I'll see you in the next one.